have, last but not least, Konostantin Dunaev from A10 Networks.
Okay, so you can hear me, right?
Right. Go ahead.
The slide is loading. I hope it's a little bit slow. Not sure why. Okay, anyway, why is it loading? So my session is to present or to discuss the A10 capabilities and how A10 can help our providers to transition from IPv4 to IPv6 and how we can support our customers and our providers in this case, right, on the journey. A second, I'm not sharing here. Okay. Okay, and many I think of you are aware about A10, or maybe not, but I mean we are very strong in the CGNAT market, right, and we are providing carrier-grade NAT approach for the NAT transmission, or we call it CGNAT specification, which allows us to preserve the existing investments in CGNAT at the same time the transition to IPv6, right, and we also provide some capability to protect against DDoS attacks, which might be coming from internet and accessing the NAT resources, right? One of our biggest challenge today, of course, right, in the market, that IPv4 and IPv6 in general architecture is not compatible, right? So I mean, if you have IPv4 endpoint, it can't talk to IPv6 endpoint and other way around, right? So you always need to decide to make the decision. You go with IPv4, with dual stack, with translation, with transition, right? And unfortunately, that state will stay with us for many years at least, right? So today now we see that transition to the IPv6 is kind of very slow. I mean, at least the last 5 years or something. But I mean, it's going forward a little bit further to their fully IPv6 network. And unfortunately, I mean, all studies say, I mean, we'll probably never reach our full IPv6 state, because we always have like some IPv4 endpoints, IPv4 resources which should be reachable, should be available. Okay. So from a A10 perspective, we provide full-blown capabilities which allows our providers to protect their IPv4 investments, right? So we provide CGNAT capabilities for NAT4 translation, NAT6 for translation, and many other IPv6 migration, right? We also provide very important and very critical capability which allows us to create the logging and be law enforcement compatible, right? So we can provide the logging for each translation, for each session, right? And so all other capabilities, for example, I mean, supporting full ConNAT, which supports for the end-to-end visibility for the application, end-to-end visibility, which is very, very critical. But at least, I mean, we have very, very flexible licensing, and I will explain this in the next slide, why it is important. As you can see here on the slide, right, so this is represents all available capabilities on A10, right? So we do support different functions like encapsulation, 6ID, DS lines, different MIP-T, translation, NAT4, NAT64, and so on. The best thing that they all are covered by the single license. It of course allows the customer or provider to create very, I mean, from the very beginning, right? They can create the roadmap path, right? And they can choose one kind of technology, right? And then can migrate to another technology. For example, they can start with NAT4 and then go to the NAT64 and so on, right? And they don't need to care about the licensing because it's already included, okay? And also this slide represents the challenge which each provider will see in their journey, because there are a lot of technologies, as you can see here, right? And the provider needs to choose which one to use, which one to go forward. And there are some restrictions, some prerequisites which we need to follow, right? For example, if the customer or if the provider is cable network, right? So they can use CPE devices. So they have the possibility, for example, to implement the technologies like DS Lite or MIP-E, MIP-T, right? From the other side, for the mobile providers, which do not usually have CPE available, right? So they need to look at another mechanism which do not rely on CPE devices. I mean, like simple NAT44, NAT64, DNS64, right? So this is one of the challenges which provider will have, because they need to see, okay, so what do we move first? I mean, do we move first access core, right, or we move first subscriber to IPv6, right? And that will define actually the path, the roadmap for the provider from the translation or from transition to IPv4 to IPv6. Okay, and the next slide is very colorful, light, and very busy slide, but we spent a couple of times on different events to go through that slide, because it actually shows possible advantages or drawbacks of different technologies in compared to the capabilities which they provide. Of course, for the providers, it's very important to be able to prolong the existing IPv4 infrastructure and allow the business growth, right? As you can see, so most of them are technologies that you do support provide that, right? For example, dual stack or DS Lite, NAT64, or MIP-E, MIP-T, right? So they can translate existing IPv4 addresses, right, and use our NAT44 translation to optimize the usage of the existing IPv4 resources on the provider. Okay. On the complexity of operation and troubleshooting, of course, I mean, all technologies which are related somehow to the tunneling, right, or some kind of translation are very, kind of not very, but I mean, moderate to high are on the complexity scale, right? You can imagine DS Lite as a tunneling, and you need to deal with two layers, IPv4 and IPv6, if something goes wrong. Okay, on MIP-E, MIP-T is even worse, because I mean it's tunneling, but it is kind of it's all information related to IPv4 translation is embedded inside of IP address. So you need to be sure exactly what is and how it is translated and embedded. Most of them, unfortunately, still breaks the IPv4 connectivity, right? Because NAT44, by definition, right, when you create NAT translation from multiple inside IP addresses to a single IP address and the port, right? So this kind of breaks. But as I mentioned in the beginning, so we follow all the RFCs, right, and CGNAT RFCs, which actually helps to make that restriction not so hard, right? So there are a lot of features like features like CGN or full CONAT and
we lost your slides, Konstantin.
Sorry, say it again.
I said that we lost your slides.
Oh, you lost my slide.
Yeah.
Just give me a second.
Yep. Now they're back. Okay, thanks.
You see my slide, right?
Yeah.
Okay, perfect. All right. And some other concepts like CPE requirements, as I mentioned. So many technologies will require CPEs, some others do not, right? The last two points or items is very interesting, right? So IP reputation list. and it relates to the fact that some of the IPv4 addresses may be for some reason be listed in, let's say, bad IP lists, right? Because those are public IP addresses used for spams, for botnets, for something, right? And this especially today when providers trying to buy some gray public IP addresses for their usage, right, to extend the IPv4 resources. It is very, very critical and important to monitor that, right? And sometimes providers will need to take additional actions, right, to clean, so to say, those newly bought IP address range from those IP reputation lists. And of course, lawful intercept process, very critical when we are talking about translation from multiple inside IP addresses to a single IP address, right? So we need to keep the track of those translations, right? And we need to keep that information somewhere because of the kind of volume of that information. So we should be we keep that information externally, right? So we do support multiple different protocols, multiple different formats, right? And those information, so we do support syslog, netflow, radios, and we can very, very flexible or configure information we can send to the external device, right?
We lost the
slides
again.
The last slide.
Credo ci sia qualche problema. Oh. Okay, we can see the slides, but we cannot hear you back. Okay.
Sorry.
Okay.
You can hear me now, right? Sorry.
Yeah.
Multitasking. Okay, and the last slide, I just wanted to bring up the use case which we implemented in our European, actually one of the largest European fixed network with DS lines, right? So the requirements were very, very high, right? It's like the nationwide provider. As you can see, they implemented about 80 devices. This is our high-end and middle-end devices, right? And they using the DS line to cover the whole country, right? So we were competing against Nokia, important wireless, right? And one of our advantage was our flexibility, right, on the configuration and price performance. Right, so the DS slide is especially that was really shown up that our architecture can reach very, very high level of the performance, and the customer was satisfied. And actually, this is probably one of our longest, not longest, but I mean at least I think like more than 6 or 7 or 8 years, right? So they are technologies and devices, and they're very heavy. So the slide for them works very well, right? And I think that's it from me right now.